Good afternoon, everyone. Thank you all for coming for this session. So in this session, my name is Vinay Balasubramaniam. I'm a product manager in the BigQuery team. I'm joined by Ian and Carolina from King, who are going to share their experience of using Looker and BigQuery. So King has transformed their business using Looker as their enterprise BI solution, and they're here to share their story soon. Now, I work in the data space, and your feedback is super important for us. So your feedback is our data, so do share your feedback about the session after the session is done. So let's get started. If you look at organizations who are going through digital transformation, they're collecting a lot of data than they used to do before. Now, data is being generated from clickstream analytics, mobile data, social media posts, or your sensor data. This particular statistics from IDC shows that in the next 4 to 5 years, the amount of data which is being generated, more than a quarter of that data is going to be analyzed in a more real-time fashion. Now, if you think about it, in the next 4 to 5 years, there are going to be about 175 zettabytes of data. A quarter of that is going to be analyzed in a more continuous manner. So as organizations, you need to invest in a big data platform which not only can analyze the variety and volume of data, but can do that in a more continuous manner. Google Cloud Platform data analytics solutions provide real-time analytics as part of the capability, which is already ready for you. But what is driving the growth of real-time data? If you look at our personal lives, we leave digital traces everywhere on a daily basis. Or it could be a business who's looking at all the sensor data and acting on that in more real time. Or it could be a marketing executive who's looking at clickstream data to understand what sort of ads they need to serve. Or it could be a game developer who's looking at all the different gameplays to figure out what sort of levels they need to customize for every use case. And if you look at this particular study from Forrester, which was published, insights which are derived from data have a shelf life, which means you need to analyze this data in a more real-time fashion so that before they perish. So on the x-axis is the perishability of data as it ages, and on the y-axis is the time to insights. Not all use cases require real-time analytics, but some of those use cases, such as the one which is where you take automated decisions. For example, you need to detect if there is a fraud happening at the point of sale application. Or it could be a consumer who's applying for the loan, and based on the credit score, you need to understand what sort of rate you need to give, right, as a financial institution. Those things are more automated fashion, which you need to act on it much more sooner. The second, on the operational insights, these are more human-oriented, where humans are looking at dashboards. For example, a consumer walks into a retail store, and as a merchant, I need to look at their past purchases to understand what sort of discount or customized discounts I need to offer, right? There is a little bit more time to act on that. On the performance insight side, you are looking at a day-old data to understand what sort of changes you need to do in your sales pipeline to act on that. And on the strategic insights, these are more longer term, where you are looking at quarter-over-quarter data to understand what sort of changes you need to do on the business side. Right, so there's a spectrum of use cases. Our vision for real-time analytics is to be the platform which allows you to derive always fresh and always fast data with no limitations as the data volume grows. If you look at BI solutions out there, they make you make trade-offs between freshness and speed. If you want the most fresh data, it's not fast. If you want the data to be really fast, it's not fresh, right? So we want to provide a platform which allows you to analyze both real-time and historical data. So if you map the same thing with what BigQuery is today, BigQuery is widely used for strategic insights, performance insight, and operational insights. But where we are investing in this year and the next year is to push BigQuery to also be in the real-time space. So you have one single platform where you can look at real-time insights and historical insights. And oftentimes we have seen customers using 2 different systems for this, right? That's where BigQuery is today. And if you compare BigQuery with what traditional warehouses are, you need to manage servers, you need to scale them, you need to patch them, you need to manage complex ETL pipelines to load data in. right? With BigQuery, we make the overall infrastructure management invisible, so you have a lot more time to look at insights, ask the questions, or even ask newer questions, which was not possible, right? But the key differentiator for BigQuery, which is unique to that, is support for real-time insights. So there are two use cases where BigQuery already does that today. So BigQuery on the ingest side natively supports streaming ingest, whereas a lot of other data warehouses require you to do batch ingest, which delays your freshness. The second area where we announced earlier this year is an in-memory analysis engine built into BigQuery called BI Engine, which allows you to get sub-second query response time for some of these dashboard-style use cases. And those are if you combine those two capabilities of BigQuery, you're really getting to a point where you can derive continuous intelligence as the data comes in, versus waiting for data to be loaded over time. In terms of streaming, BigQuery, when it was launched a few years ago, we supported both batch and ingest streaming mode ingestion. But we had certain limitations in terms of how much we can scale, right? Because it was built for what real-time insights was a few years ago. But since then, we have seen a lot of customers moving from batch to streaming mode ingestion. So we took time last year to create a completely new backend for BigQuery streaming. And this particular backend right now is in beta, and that can really scale, right? We removed some of those limitations which we had with current streaming. The default ingestion quota we give for all streaming ingestion with the new backend is 10x more than what it is to be. So it's about 1 million rows per second ingestion. And we have tested it up to 20 million rows per second ingestion. That's pretty massive in terms of how much you can ingest. Also, not only on the ingest side, but also on the read side, the performance, the read latencies have significantly improved. As you start streaming data in, you can read them at a much lower latency pace, and that's improvement on both sides. Sometime next year, we're going to have a new API for streaming, which is binary, which has native Avro support. And that makes the overall platform for streaming much more richer for you to build real-time insights on top of BigQuery. The second thing which we announced earlier is BigQuery BI Engine. A BigQuery BI Engine, for those of you who have not heard of it, it's an in-memory OLAP engine which is built into BigQuery, right? It's a column-oriented database on top of BigQuery storage, and it can horizontally scale. So especially built for dashboard and reporting style use cases where we have a lot of concurrent queries, and all of these analysis happens in the memory layer, right? So it can scale horizontally, so as you have a lot more queries coming in from your dashboard, BigQuery BI Engine can automatically scale to support concurrent queries. And BigQuery BI Engine natively integrates with BigQuery streaming, so as data changes, we can incrementally update that data in memory and to make your freshness of the data much more quicker. If you look at traditional BI tools, they require you to take the data from your data warehouse into the in-memory layer for it to be fast. But that comes with a lot of architectural complexity in terms of managing an ETL pipeline. With BigQuery BI Engine, we have taken the same OLAP idea and baked it into BigQuery itself. So it sits on top of BigQuery storage, and we can move the data from the BigQuery storage layer into the memory layer much more seamlessly. And that simplifies your overall ETL, and there's no need to move data outside of BigQuery. When we launched it, we announced BigQuery BI Engine only with Data Studio, but we are committed to delivering a SQL API to make it available outside of Data Studio. So tools like Looker, Tableau, any of the existing tools which can talk to BigQuery through JDBC, ODBC can still make use of this particular engine, and that is sometime next year. BigQuery BI Engine also has a notion of smart tuning, so it really doesn't cache all the tables. It only caches the columns which are being used in your dashboard, and it can automatically tune the column based on different encoding types, and it keeps the data compressed in memory, so that way your if your table can be bigger, it can still handle a lot of data. And in terms of reservations, it starts as small as 1 gig. You can create 1 gig increments of reservation, and you can go up to 50 gigs. But as we make the SQL API available, we're going to allow you to add a lot more memory layers. So you can really, if you have a bigger table, you can pretty much keep everything in memory. And a lot of data about the BigQuery BI Engine, how it's being used, what sort of caches, how much time we cache the data, what kind of data is being cached, is published in Stackdriver, so you could get visibility into understanding how much more memory layer you need to do. So here's a great example of a customer who has taken this journey with us, Zulily. For those of you who are not aware of Zulily, Zulily is an e-commerce company based in Seattle. They use AI and machine learning to offer a personalized shopping experience for users. When they started off, they were on-prem in a colo using traditional data warehouse technologies and Hadoop. So they were collecting data on a regular basis, but their whole pipeline was slow, and the data used to be analyzed every 24 hours, and that was not good enough for them to understand what sort of daily deals they need to offer to the customer. Since they moved to BigQuery, they started streaming data into BigQuery, and they collect a lot more data points. For example, today they collect up to 50 billion data points about different parts of shopping experience of users, and they are able to create new shopping experience, new products dynamically based on the data they've collected. And since then, they've really added a lot more users within the organization, a lot more customers to their site, right? So this is a great example of a customer who has transformed their business and still staying competitive with Amazon, right? So they're able to do that because they've invested their time on BigQuery as their data platform of choice. So last year, earlier this year, we announced the acquisition of Looker, and that's a great complement to what we are doing already with BigQuery, but acquisition is still pending, so I cannot share a lot of details of what we want to do jointly. But essentially, the key point is, with Looker, we have a lot of data about joint customers who use Looker and BigQuery, and these customers who have taken this journey of using Looker as their BI platform love it, right? And that's one of the reasons we felt there was a really good synergy between what Looker was offering and what BigQuery was providing. And if you look at the overall portfolio of our stack, we have services on the ingest side, we have services on the analysis side, but what we were missing is the last mile of delivery. We were relying on our great partners to offer the BI solutions, right? And a lot of our customers wanted an out-of-box experience from Google. And Looker really fit in that category, right? We will still continue working with all the great partners we have in the BI space, but we are also going to offer a first-party experience with Looker. Now, what makes Looker highly differentiated and complements to what Google already provides? So with Looker, we provide an end-to-end data analytics platform from ingestion to BI. And Looker fits very well with Google Cloud's multi-cloud strategy. Looker runs on GCP, AWS, and Azure, and we'll continue to support that. And Looker connects with all different data warehouses, including on-prem databases. We'll continue to do that. So it fits well with our open cloud strategy. The second thing is the common data model over your data. There are a lot of BI tools. We provide self-service BI, which allows you to connect to your data source and then create these dashboards. But the challenge with that model is that every department gets their own view of this data, myopic view of the data, and there is no single unified source of truth of what's going on, right? With Looker, what they've done is they've invested in a modeling platform so that you can express your business logic, you can express your KPIs in a more centralized manner, and then you can provide that access to your dashboards so that different teams, when they look at churn data or revenue data or net revenue data, it's all consistent, right? So there is a little bit of upfront work in creating those data models, but once it's created, it's widely used by the organization. And King is going to talk about how they have transformed their business using LookML. Third thing is where Google complements Looker is around augmented analytics. This is where we can Google brings the machine learning and AI technology right into your BI tool, right? This could be where you can use machine learning models to understand or predict how your churn is going to happen in the next few months based on past data. Or it could be where you can predict will the customer buy this product, right? This is where you blend AI seamlessly into your BI solution. And that's where Google Cloud Platform's AI capability can come in. And lastly, we want to help our ISVs and SIs to build data-rich applications with Looker as the data platform and BigQuery as the data warehouse. So with that, let me invite Carolina, and she's going to share how King has started using Looker as their enterprise BI solution.
Thank you, Vinay. Good afternoon, everyone. I'm Carolina Martinez, and I have been working at King for 4 years now. Currently, I'm working for the incident management team. Today, with my colleague Ian, we want to talk to you about how we use Looker at King. Ian will explain how we did it, why we migrated to Looker, and the benefits it has provided. Afterwards, I will show concrete examples on how we use Looker in the incident management team. But first, for those who don't know who King is, we are better known as the makers of Candy Crush. We are a games developer. We developed more than 200 titles, of which 18 are currently live. Our games are played all over the world by 247 million people each month. And we are currently located in studios and offices all over the world, and we are more than 2,000 employees currently. And since February 2016, we are part of Activision Blizzard. But how does King look like in terms of data? First, you can see here a selection of our most popular games. You might have played them at some point or heard of someone just playing them. Behind this, in terms of data, we have 7 billion events generated daily from our games and consumed into our data warehouse. We count at the moment 500 terabytes in fact tables and 60 terabytes in dimensions, which equates to 3 trillion rows and 500 billion rows, respectively. On a daily basis, this data is systematically processed in BigQuery. I can show you briefly how this happens behind scenes. So we have a combined batched and streaming infrastructure that allows us real-time capabilities as well as robust and complete analytics. Regardless of how we ingest this data, we can have real-time anomaly detection. We can explore this data using the typical data scientist toolkit with R or Python developers. And we can also explore this data with Looker. Also, we ingest this data and ingest it into other analytical apps. In this environment, Looker has played a very interesting role and has expanded our capabilities of analysis. So next, Ian will talk you through how and why we moved to Looker.
My name's Ian Thompson. I've been working BI at King for over 5 years now, and I'm currently looking after the BI platform. Google asked me to talk today about our journey with Looker, a little bit of information about how Looker works, and a use case we've done with Looker and BigQuery. We started with Looker about 3 years ago when it won an internal BI evaluation for a complete BI solution. And it became our main BI tool after just 1 year. After 2 years, it was our sole BI tool. King also completed its migration to BigQuery from an on-prem Hadoop cluster and MPP database. It was about 18 months ago. But let's take a quick look back in time to see what our problems were before we started with Looker and what we needed. So our biggest problem was that we had one team bottleneck. So we had one team in charge of reporting with a huge backlog, which meant that we had minor changes that had to wait. We had many reworked copies of all sorts of reports and data models, and that led to lots of duplicated code and lots of wasted effort. We had no single source of truth, really, and people were defining what should have been standardized dimensions and measures in varying different ways, which results in different KPIs, and that led to a lack of trust of the data and the tools. That led to rogue behavior, and people were spinning up all sorts of different solutions and software. Users found it quite hard to adhere to a single source of truth model because the processes were quite complicated and the workload was quite heavy. And we had no traceability or responsibility. So who owned these products and where were they running? Was it in someone's personal schema? And who was going to action these bugs if they came up, or any edits on the solution? So what did we want to achieve by integrating Looker? So we wanted to disperse our engineers. We wanted to embed our BI engineers into the business to be a dedicated resource. And we wanted to empower and devolve building those analysis to those who fully understood the subject matter. The BI team understood best how KPIs worked, but not the intricacies of how the different games and campaigns worked, for example. We even wanted to empower and devolve people who understood the data best. So the BI team, they understood the core data model really well, but they might have struggled to understand the intricacies of data from all sorts of platforms across the business. We're better at assisting rather than bouncing a solution back and forth until it's perfect. And we wanted to get the decision makers closer to the right analysis, and they needed to get closer to the process. So we need the decision makers sculpting the landscape of what actually could be analyzed. So this is a useful time to take a quick break from how we rolled out Looker and see how Looker works and how simple its SQL abstraction language called LookerML actually is. So at the core of the Looker data platform, and not seen by the majority of its users, is a query builder. So you describe the attributes of your database data model and any business logic to Looker just once, and Looker is then capable of building and running tailored SQL queries based on what the user wishes to know. And this is known as exploring in Looker. The abstraction from SQL has many positives and is coded in a language called LookerML. LookerML is a language for describing dimensions, aggregates, calculations, and data relationships in a SQL database. And Looker uses a model written in LookerML to construct SQL queries against a particular database. So for some context, I wanted to show you what an explore actually looks like. So this is your explore page that you're faced with in Looker, and the user is able to select from the left-hand panel there some fields to create their analysis and visualize that result set. So Looker will create a necessary SQL query based on the LookerML to fetch these results from the database. So what are the benefits of LookerML? Looker say that LookerML isn't a replacement for SQL. It's a better way to write SQL, and I agree. Some of the major points of the benefits would be reusability. So the majority of data analysis isn't likely to be used again, yet a lot of the same steps would be. So with LookerML, you define a table, a dimension, or a measure, or a relationship just once, and you build upon it, rather than rewriting the SQL every time. Version control. So ad hoc queries and multi-step analysis is very difficult to manage and version control. With LookerML, version control is built right into the tool, and you can integrate that into Git. LookerML is also architected to make collaboration natural and easy. And we also love that it can empower others. So no longer are there secrets of how and why things are designed and defined. Everyone's able now to chip in. So this is a very, very quick introduction and example of LookerML. And we can see here we are defining the orders data set in LookerML. So the majority of LookerML is auto-generated, and it's very quick and easy to enrich. In this orders data set, known as a view in LookerML, there is a dimension, which is based on the ID field from the database. And that also has a name, a data type, and is marked as a primary key. Here we can see a few more dimensions. And for example, we have a formatting change there, and we've also got the created time dimension. In LookerML, someone has decided there to expose the time, the date, the week, and the month, and that will expose itself in the front-end LookerML Explore nicely and easily to the user without you having to specifically code week, date, month. At the bottom, we have a measure, which is a sum of the amount field in the underlying database table. So this concludes our orders view, and we can now see how this is actually utilized. So this is the explore definition. And an explore is how you offer your users to create an analysis. It's the playing field you offer to them. So in this case, we can see that we have the orders data set and any customers that may have made those orders. Depending on what dimensions and measures the user actually selects in the front end, Looker may or may not include the customer's data set into your underlying query. Looker will always create the most performant query to execute against your database in order to get the results the user is actually requesting. The collection of all of this LookML is known as a model. So that's a very simple example of LookML there, and it needn't be any more complicated than that to add some serious value. I personally love LookML because of its ability to deal with the complex issues while still remaining clean and simple, along with some of the other benefits I mentioned earlier, such as the reusability is a big one, and how easy it is to collaborate when working with LookML. But let's get back to how we rolled out Looker inside King. So how do we integrate Looker? We ran POCs with teams disillusioned with the BI offering at the time. It took off, as shown by a rapid decommission of our other platforms, and we did this by running hands-on workshops with people, where we'd start off with an introduction to the tool, and we'd actually end up building a product with them, so the team left with a working solution. We would always make sure that we were on hand and were proactively searching out issues in order to make the adoption as simple and satisfying for our users as possible. Our power users were also at the heart of our success. They would do a lot of our work for us from inside their own teams. And we also introduced a concept of what we call core models. So what is a core model? We think a core model for us is owned by a specialized BI team who best understand KPIs inside King. Teams are then seeded with this core data model, which is a starting foundation point for them to build on. So for free, they get all the KPIs and the ability to add, edit, and remove bits for themselves. And because of this, there was a lot of buy-in from them as well. They owned something for themselves. They were free to express themselves and could truly tailor the experience for their own business areas. The solution of this is, I feel, very robust, centralized, and controlled, yet adaptable. But this is only possible through extension in LookML. So what is extension? In short, you inherit everything from the parent object as you can alter and include new attributes. And when I was putting this slide together, I lazily Googled the word extension, or extending, and I was faced with loads of extending tables. And I feel this is almost a perfect metaphor, so long as you are a carpenter, for example. You'd be crazy to discard a 6-seater table to build a separate 8-seater table. You'd be much better off adapting your 6-seater table to make it an 8-seater table for the few times that you actually need it. And you could reuse your perfectly suitable table legs and perfectly suitable tabletop. Regarding King-specific use cases here, we couldn't possibly cater for all of every single game nuance to build different metrics. We can cover the standardized ones and allow teams to extend our model to include their own. So when we merge the concept of our core models with LookML extension, it's incredibly powerful. We seed teams with this model, and they can add value by tailoring it to their precise needs. This results in a single source of truth, which is based on a secure code base and saved in Git. We now have traceability. We can track all models and analysis back to the data warehouse and the ETL. We can distinguish owners of parts of the model and assign responsibility, and teams can really focus on the differentiation. So a few years ago, King started working in partnership with some small independent game studios. And King support these studios in many ways, one of which is offering analytics. Our partners could leverage our analytics offering through Looker to improve their marketing campaigns, to improve gameplay and engagement, and obviously increase sales. We're currently refactoring the data ingestion process for our publishing partners, but this is a use case based on a proof of concept with a very light touch ETL. So let's take a look at how we created this multi-tenant analytics service for our partners. So we ingest all of our publishing partners' data combined into one GCP project. And we create a useful data model from these events. Our internal publishing business performance unit, otherwise known as a BPU, may also wish to create some tables specific to publishing. We expose only individual partners' data to that partner. In order to do this, we create a GCP project for that partner and every partner, and the data sets of what we want to expose are created one-to-one mapping with our source data. And each object there is exposed via an authorized view from the source data. This allows us to do column and row level access and offer our partners something different for each partner. These views are built programmatically in the partner-specific projects in an authorized view. So inside Looker, it starts with our core model that we looked at earlier. And we allow our internal publishing BPU to extend this model to apply standardized publishing data additions, whatever that might be. This is then extended a further time for each partner. And that's where partner-specific additions are made. These models are configured to read the partner-specific GCP project we saw before using a partner-specific service account. Employees from these partners access Looker, and due to permissions, they are only able to access their own models. There are a couple of other safety nets put in place here as well, not shown, that would stop accidental access to other partners' data. So I'm going to hand back over to Carolina, and she can talk to you about the incident management process.
Thank you, Ian. In the incident management team, we have benefited a lot on this transition to Looker. Let me introduce you briefly how we work in the incident management team and what we are responsible for. In the incident management team, the process has 4 steps. It's detection, investigation, communication, and post-mortem. Detection, when an incident occurs, the first step is to detect and determine if what is going on characterizes as an incident. This needs to happen as fast as possible. Once detected, investigation comes in. Our analysts in the team jump right into analyzing the impact and the root cause of the incident. Communication. At the same time, the incident managers start and keep conversations with all involved parties, teams, and potentially impact stakeholders. When the root cause is found and the fix is rolled in place, a post-mortem is run, and this is all about retrospecting, defining, and following up on actions so that that type of incidents do not happen again. Swift and fast detection and investigation is crucial for incident resolution, and they depend heavily on reporting. For this, Looker has become a must. Before having Looker, the data and the model belonged exclusively to the data engineers and BI developers. All investigations were limited by what was in the backlog of the data engineering and BI development team. There was also really strong dependency on how well requirements were transmitted and understood by all involved parties. The fact that we had a central team and data engineers and BI developers were only part of that team was making it really difficult to have a dedicated person when an incident was happening, and it depended a lot on workload. At the same time, for exploration, there was a need to delegate deeper investigation to data scientists, since it was required to have specific skills for R development and Python. And as this capability to dig deeper was limited by the tech, the incident managers were forced to go back and forth to developers and engineers for constant redesign. This was having a very important impact on resolution and was limiting the capacity we had to be fast and quick in resolution. With Looker came in with fresh air. It allowed us to bend inside teams that engineers and BI developers, and the line between stereotypical roles got blurred. As iterating in Looker is very quick through the flow you can see on the slide, this empowered all users to own their data, independently if they were developers or not. For the incident management team, this empowered everyone to tune dashboards, looks, explores, and add extra tweaks and extra logic to the existing ones. Even the more bold just dare now to look into how the data model works. All parties involved feel now included in the analytics process, and rather than being just an end customer, they can also become a creator. In the words of one of my colleagues, incident manager, he said, with minimal knowledge, I can just create dashboard and create my personalized on workspace for an investigation. This gives them freedom to investigate and to load data as they need, with less dependency on the availability of engineers and developers. They can also easily interact and collaborate with other data users and share with data scientists and engineers dashboards collaboratively. So everyone can just add their best to this, the current investigation. So more flexibility gives us a better investigation capacity. Next, I'm just going to go through some use cases. We use Looker for traditional dashboarding, to load events, to explore those events, and for interactive dashboarding. Traditional dashboarding is very simple in Looker. It allows us to just integrate in one single view different data sources with different representations in a single unique dashboard. This helps us tell a story. More importantly, when investigating and analyzing, it allows to correlate the different data sources with only a glance and dig deeper when an anomaly is spotted. How dashboards are built, they allow us to just click on each tile and then explore from there and create a new explore based on the same data and start a whole new investigation based on what we saw previously in the dashboard. So next, I'm going to just show how simple it is to add new data into one dashboard. Thanks to how Looker is structured, it is very easy for any user to add new data. They can go to the development modes. They just head directly to the model of interest and click Add Data. When they create views from tables, they can just link into views that exist directly in BigQuery, and with one click, voila, they have a LookML with only information ready to explore. Next step, we add the new Explore to the model. It can be joined with other tables. It can just be an Explore dependent on the data we just linked in, and we can visualize. Once this is done, data is of interest. This can be saved into the initial dashboard we were looking, and one non-deep data development person just can just continue go adding information and going through this loop and investigation. Another very powerful tool we have at King is Slack bot that integrates, allows us to integrate data and Looker dashboards into conversations. So we have a bot which we can ask questions, and then this bot launches queries against Looker, and Looker comes back with an answer, being it in a form of a number or a graph. This is very useful when communication's going on, because it allows us quickly check without having to change context, without having to change the tool we are at the moment working with. This one allows us to fuse together communication and exploration. Last but not least, we are making use now of interactive dashboards. We use Looker as a front end, thanks to actions, where we can ask the users parameters for an investigation. These parameters are collected. This is sent to Cloud Functions. And in Cloud Functions, we can execute Python packages developed by our data scientists. They can just work their magic, dump results in BigQuery, and from there, results can be explored, analyzed, and of course, visualized back in Looker. This is a very simple example of an interactive dashboard where incident managers can select a game. They can introduce training dates for a model, which dates they want to run the analysis on, and all this data is collected. And thanks to the LookML that's behind scenes, with actions and calling to Cloud Functions, data is processed, dumped back to BigQuery, and the user can just see a completely new analysis that they run by themselves. Next, I'm going to just head back to Vinay. Thank you very much.
Right. Again, thanks Ian, thanks Karina. So the incident management is a good example of a data application, right? Where you could use Looker as a platform to build data apps powered by BigQuery, and you can share that as a Looker block within your organization. So to summarize, a few call to actions: BigQuery streaming. We have a new version there. There's a recent blog we have written on what the streaming offers. Tomorrow there is a session which covers all the new enhancements which is happening in the data platform, including BigQuery. So if you can attend that session, that'll be great. It talks about the roadmap. And lastly, King also has a very technical blog which describes the solution which they built with Looker, and in general what they're doing with BigQuery. So with that, again, thanks for coming. Again, if your feedback is very important for us, so take some time to give us feedback and have rest of the good conference. Thank you.